You have an existing wireless network. You wanted to find out the performance. Is that doing up to the maximum performance, or is there any wireless site impairment, or is there any problems due to the wireless deployment? So that is your main objective. How do you proceed to systematically troubleshoot your Wi-Fi network? That's typically the objective of the series of videos which I'm going to upload. So they will all be talking about what are the various steps involved in systematically finding a problem in a wireless network, troubleshoot it, then fix it or eliminate it completely. That is what we are going to look into this video. In order to perform the wireless site survey and then site impairment analysis, what skills are necessary? The very first and important skill is that you should have a knowledge on wireless communication technologies. Without that, definitely it is not possible to appreciate the existing network or find out problems. The second important skill is that you should have a knowledge on Wi-Fi analysis tools. There are several Wi-Fi analysis tools available. In my later videos, I'm going to discuss mainly on free tools which can be installed onto an Android or an iPhone or probably Mac devices, iPad and so on. Also, I'll be talking about some of the trial version as well as free softwares available to be installed on Windows, which also can do bit of an analysis of the Wi-Fi signals. It is essential that you need to have a knowledge on these two domains. The third important aspect is that how do you marry these two concepts together? You have to apply your wireless communication skill and the analysis tools to identify what are the issues with the current Wi-Fi deployment. And also you should be able to effectively provide a solution. So now I am going to actually give a very quick introduction to Wi-Fi networks. So this is typically, it is not a full course on wireless technologies. It is just a quick introduction to Wi-Fi. So that's why I call it as Wi-Fi 101. To start with, what are wireless signals? How they are distinct from the wired one? Wireless signals are electromagnetic waves. If you are looking into wired one, they are simply electrical signals. So here there is an add-on which is a magnetic component. Electromagnetic waves, or they are also called RF waves, radio frequency waves. It is a fluctuation or variation of energy that consists of both electric and magnetic fields. So what happens in reality? The electric and magnetic fields oscillate. They are in fact right angle to each other. That means that the angle between the electric and magnetic fields are 90 degree. They oscillate them and they move out of the propagating antenna in the direction related to the shape of the antenna. So what that shows, so if you got an antenna, then whenever it emits electromagnetic radiation, it will actually move away from the antenna. So it won't go towards that one. That is one of the reasons that the antenna start transmitting, then we are able to pick the signals. This is a very simple diagram which explains about the electromagnetic propagation. If you look into that, this is an electrical field. This is a magnetic field, so the angle between them is 90 degree. And Once this generating wire generates a signal, it moves away from the generating wire. If you consider this as your antenna, which propagates the signal moves away from the antenna. So that's how it works. Being said that, what could go wrong? If you are talking about an RF wave which contains both electric and magnetic, so any magnetic interference can disturb your signal. If you go back to the wired version it only got electrical signals. So any electrical interference can affect your signal. The same way here, if you are looking into RF signal, an electrical interference can affect your RF signal, the magnetic interference can affect your signal, and so on. So that's more difficult. Here the RF waves are more difficult to handle and it are prone to errors and so on. We are now going to look into some of the important RF parameters. There are four things which I listed here which are considered as an important RF parameters. Number one is a wavelength, two is a frequency of a wave, the third is amplitude, and the fourth is phase. We will look at each one of them and see what they are. First, looking into wavelength. Wavelength of an RF wave is calculated as the distance between two adjacent identical points on the wave. For example, if this is the wave and mark identical points, for example A and B are identical points. If you mark C here then D here, so they are identical points. You measure the distance between them. So you draw a straight line which goes from A to B, then measure its distance. So that's considered as the wavelength. Now question is that why would I need to know about the wavelengths in performing sight impairment? First important aspect is that the wavelength dictates the optimum size of the receiving antenna. If you got a particular wave with certain characteristic, then that actually determines what would be the size of the antenna. If the antenna is too small, then it may not be able to receive. If it is big, that's fine. The same way, the RF wave also will interact with the environment that depends on the wavelength. For example, if it strikes an object which is larger than the wavelength, it behaves in a certain way. If it strikes an object which is shorter than the wavelength, it behaves in a different way. So that is why when we are looking into the impairment, you are actually going to find out, is there any object which typically reflects or refracts, or how actually it attenuates the signal. So that in order to know that, you need to know about the wavelength. So that's why it's a very important parameter. The frequency refers to the number of wave cycles that occurs in a given window of time, usually in 1 second. There is a bit of a relation between the frequency and the wavelength. They are connected by the formula lambda is equal to c over f, where lambda is the wavelength and c is the speed of light in vacuum, which is 3 into 10 to the power of 8 meter per second, and f is the frequency. Or indirectly, lambda f is equal to c. So in a way, frequency and wavelengths are all interconnected. If you know one, you can always find out other. Since I am talking about wavelength is very important in order to know the antenna size, then you need to know about the impairments it's going to cause and so on. In the same way, I am also going to repeat it again. The frequency is also important because they are all interrelated. So you give attention to one of these parameters. You don't need to actually worry about these two together. You give attention to one of the parameters. So usually we will be worrying about the wavelength. So that's what we are going to look at it. Then looking into the wavelength and then see that how that's going to actually affect. The third important parameter is called amplitude. Amplitude is actually the measurement of height. It is also called the signal strength or power. If you are looking into an RF wave, if it got a greater amplitude, then it's easier to detect. If it got a lesser amplitude, it's difficult to detect. And also, if it got a greater amplitude, it will travel to a long distance. If you got a lesser amplitude, it can't travel to a longer distance. And if there is another factor which is called noise floor. Now I am talking, there are some background noise. Since I am talking loud enough that you can't actually feel the background noise. If I just talk so feeble, then the background noise, if it is too much, you will start actually hearing more of a noise than what I am talking. In the same way, if you are talking about the wireless waves, if the noise floor exceeds the amplitude of the wireless signal, you will not receive anything. The same way, if the difference between the amplitude of the noise and the amplitude of the signal is too small, it will be difficult to distinguish which is the noise and which is your signal. It is better to have a good higher amplitude, but higher is always not possible to achieve all the time. There are a lot of regulations available, and also there are a lot of health restrictions, so you can't. It is impossible to have a very high amplitude so that you can detect all the time, then it travels to a long distance, which is not possible. You may ask another question, can I reduce the noise floor? Obviously that's also is not possible. It is not possible to reduce the noise floor as well because it is actually location dependent. You need to live with what is available. The noise floor you cannot change it. Then the amplitude you can only get certain amplitude, so you can't go beyond that. With these two parameters, how do you manipulate? How do you actually looking into getting the best out of it? That's where is the challenge in wireless network. The fourth parameter, which is not directly related to a wave, we have seen wavelength, frequency and amplitude. That's all related to a single wave. If you are looking into one wave, you can talk about its frequency, you can talk about its wavelength, you can talk about its amplitude. When you are talking about the phase is something you have to have at least two. It is something like a height. Who is taller? If you wanted to know who is taller, who is shorter, you need at least two people. Without that, you cannot talk about tall or short. The same way, you need two signals to find out are they in phase, are they in out of phase. Take the first one, the topmost one. That's my primary signal. If you look into the secondary signal, they are almost, when it increases, so when it reaches the maximum, it reaches the maximum. When it reaches the minimum, it reaches the minimum. Then again goes like that. So we call that these two are in phase. If you look into this, they are actually out of phase, 180-degree out of phase. So whenever it is in the maximum, it goes to the minimum. When it goes, this one goes to the minimum, it goes to the maximum. If you add these two waves, actually they cancel each other. Then you get nothing. This may not be important if you just look at it independently. You may ask the question, why I need to know about the phase? If you are talking about when in a wireless signal, you are going to have multiple signals coming. So what if one signal is out of phase to other signal? Then they are going to cancel each other, and at the end of the day you are not going to get anything. If two signals are in phase, they add each other, but if two signals are in 180-degree out of phase, they are cancel each other. So you need to actually evaluate this. Can you measure it? The answer is no, you will not able to measure this. But however, you have to have it in your mind. When we do an antenna design, we will be looking into how to ensure that they actually produces in-phase signals and so on. So typically, this will be my next video. My next video, I'll be talking about mostly on Wi-Fi channels. So what are the channels available? Especially we are going to talk about the frequency, what frequency our home Wi-Fi operates, then how many channels are available, what are the problems with the channels, or what are the advantages, what are the disadvantages, what I need to know in order to move towards sight impairment project.